Yes, audible.
Hello guys, good afternoon everyone. So today's our topic is about AVL tree, B tree and B plus tree. It's about the data structures part. It is the data structure part. We are learning about these three trees, AVL tree, B tree and B plus tree. Already we have learned about the tree data structure, its terminology also, and we have also seen the insertion, deletion and traversing of the tree part. So let's see how these three types of tree are working here. Let's move on and see how they work. So first is our AVL tree. So AVL tree is a binary search tree in which difference of heights of left and right subtrees of any node is less than or equal to 1. So we will see in AVL tree what it happens. The difference of the left subtree and the right subtree. If this is a tree, let's see, I am drawing a tree here. If this is a tree, so in the AVL tree, it is saying that the left subtree and the right subtree, the node, we will find a difference in these two nodes, then the answer should be either 1, 0 or minus 1. This 3 is the value of the AVL tree, the balance factor of the AVL tree. Not more than 1 or not less than minus 1. So it will be between minus 1 to 1. Not more than that, not less than that. That means the three values from minus 1 to 1, there is three values, that is minus 1, 0 and 1. So we can say the AVL tree as the height balanced tree also. We can say it as the height balanced tree. The technique of balancing the height of binary tree was developed by Adelson, Welsky and Landy. These three persons made this technique. That's why the name was given as A, V and L. A for Adelson, V for Welsky and L for Landy. These three names are given by these three persons. This tree is named as AVL tree, or you can say it as balanced binary tree. Clear everyone? Remember this name? They don't ask, but just for your benefit, just remember it. The name is Adelson, Welsky and Landy. It was developed in 1962. We can say it as AVL tree or we can say it as balanced binary tree. So the balance factor of a node, as I said before, there are three values, that is 1, minus 1 and 0. Not more than that, not less than that. The balance factor should be between minus 1 to 0. That means minus 1, 0, minus 1 to 1, minus 1, 0 and 1. Remember these things. Tree is said to be balanced if balance factor of each node is in between minus 1 to 1, otherwise the tree will be unbalanced. See, if I will do a tree here again, this one. So what is the height of the tree? Can anyone say me what is the height of the tree? What is the height of the tree here? What is the height of this tree I have made here? From this node to this node, it is 1. From this node to this node, it is 2. That means my height is 2 here. Yeah, right.
The height of the tree is 2.
So it is 2 here. My height is total, the height of my tree is 2 here. Okay, fine. So height of this tree, this node. I'm circling this node. What is the height of this node? It is 1, obviously. Here there is no leaf node. Okay, I'm drawing it again. This is one node, left subtree, right node, another one here, and the one here. What is the height of B? I'm naming this one. The height of B is 1. So we will see how to balance the what is the balance factor, how to know the balance of the AVL tree. This subtree, let's see, it is C and this is D. In the C, there is no more leaf node. Is there some child node between C? No, there is no leaf node. So it is a leaf node. C is itself a leaf node because there are no child of C node. So it will, what will be the answer? 0. There is no leaf node in the left side, also no leaf node from the right side. That means 0 minus 0, that will be 0. In here also, in the D node, in the D node, there is also no left subtree, no right subtree. That means this factor will be also 0. But in the B node, there is left child is 1, right child is 1. That means 1 minus 1. What it is? 0. Here, let's see, say this is I. In the I there is also no left subtree, no right subtree. That means the balance factor will be 0. Let's say it is A. In the A node, what is the height of A node? Here in the left side, it is 1. This is 1 and this is 2. That means it is 2. There is 2 in the left subtree. And in the right subtree, there is 1. 2 minus 1. That is equal to 1. Yes, this tree is balanced because 1 is one of the balance factor. Clear, everyone? We will see further. We will see the example. Are you clear in this example?
Yeah, clear.
Yeah, it's clear. Okay, fine. Let's move on. Balance factor. See, the balance factor formula is this one. What I have did it now only. See, height is saying the balance factor. Height of left node minus height of right node. See, what is the height of left node? It was 2, right? And the height of right node, it was 1. 2 minus 1, it is 1. It is a balance factor. Clear, everyone? So let's move with an example. See, I have made an example here. We will go from the downwards, right? From the bottom only we have to go. Otherwise, we can't find it. We have to go from the bottom to see if each node is balanced or not. Otherwise, the tree cannot be called as a balanced AVL tree. So from the bottom, see F. F is a leaf node. It does not have any subtree. It does not have any child tree. That means the balance factor is 0. In the G, okay, I am doing here. B. First, let's complete this one. Then only we will go to this part. F has no child node. That's why its balance factor is 0. G also doesn't have any child node. Its balance factor is 0. Done. This part is over. This part is over. Now, which part we will see? E part. Okay. In the E part, the height of left subtree is 1. It is written 1. A height of right subtree is 1. It is written 1. So 1 minus 1, we have to subtract it. What is our formula? The formula is height of left subtree minus height of right subtree. So what we came to 0. That means it is also balanced. This entire tree is balanced. It is also forming a tree, right? Its entire subtree is balanced. This part is over. Now we will go to the D part. So in the D part, what you are going to see? See, no child node. That means this part is balanced. It is 0. It's over. This part is again over. We will see to the further leaf nodes which are there. So in the further leaf node, see H. H has no child node. That means it's 0. I have no child node. That means it is 0. The balance factor is till now all are in a balance factor. All the subtrees are in a balanced factor. Now let's see further. In the C, in this C part, C node. In C node, the left subtree height is 1. The right subtree height is 1. 1 minus 1, it's 0. Yeah, it is a balance factor. The C is a balance factor. Means this subtree is totally a balance factor. Now, here in the B part, can anyone say me what is the height of the right subtree? What is the height of the right subtree here?
3.
Okay, how is 3, Himani? Can you please explain me? How it is 3? Yeah.
A to B, then B.
No, I am asking about B only. I'm not asking about A. I'm asking about
Okay. Okay, B में right subtree की height है 2.
Height है 2, right? How you find it? From B to E, there is one height, and E to F, there is one. So there is a height of 2. So the right subtree height is 2, and the left is 1. That means, is it a balance factor, Himani?
Yeah.
-1 is a balance factor or not?
Balance factor है ये.
Yeah, correct. So it is a balance factor. That means our this left subtree is also a balance factor, and right one is also a balance factor till now. Now, okay. Now say me, what is the height of A? The left subtree height of A. What is the height of the left subtree? Entire
3.
left subtree. Yeah, it's 3. 1, 2, 3. Yeah. So it is 3. And the right subtree we have the height is 2. That means 3 minus 2 is 1. That means the entire tree we have drawn here is a balanced tree. Clear, everyone? So let's do another example here. Does anyone have any doubt? You can ask me now. Anyone having any doubt?
No, Jaya.
Oh.
No.
So, say me, is it a balance subtree or not? Anyone? Say me, is it a balance subtree or not? I'm giving you 1 minute time. Please say me, is it a balance subtree or not? This tree I have drawn here, say me, is it a balance subtree or not? I want an answer from each of you, please. Please give me your answer in the chat box, or you can unmute yourself and say me. Okay, Himani, got your answer. Thank you. Let's see. Let's wait for someone. Okay, Svetarina also said yes. It's a balance subtree. Somyo, I want an answer from you. Please give me your answer. Balance. Okay, Somya. Okay, balance. Priyanka. Okay, Priyanka, take your time. Okay, balance. Priyanka also said. Everyone said me it's a balance subtree. Okay, Swatidi, I got your answer. Fine. So let's solve it. So say me, what is the balance factor of D?
0.
0. Of E?
0.
Okay. F? It's also
0.
0. Fine. What's the balance factor of B?
1 minus 0. 1.
That is 1. Right. What is C?
1 minus 1. 0.
Right. Correct. What is A?
2 minus 2. 0.
Correct. 2 minus 2 is 0. Fine. So everyone is clear about this. Yeah, Priyanka, I got your answer. Yeah. Thank you, Priyanka. So everyone is clear with this balance subtree. So if we will see, if there is a no balance subtree, if the tree is not balanced, then what we have to do? We have to balance it. We need to balance the tree. That's only we can say that it is a height balanced tree or it is a balanced binary tree. So to balance it, there are certain rules. Let's see what are they. Balancing an unbalanced tree. To balance itself, an avial tree may perform the following 4 kinds of rotation. See, these 4 kinds of rotation are used to balance a unbalanced tree. First one is your left rotation. Second is your right rotation. Third is your left-right rotation. And fourth is your right-left rotation. We will go through it one by one. So these two rotation, this left rotation and right rotation, is known as single rotations. Why it is known as single rotations? Because see, the left rotation means the problem is like, I will show you in the next slide how it is being, why it is said as single rotation, and why this left right rotation is said as, why this left right and right left rotation is said as double rotation. This is the left rotation problem, left rotation solution. Why we are saying it is single solution? Because see, the problem is right to right, means when a tree, if one is a node and having another node in its right subtree and another node in its right subtree, means a tree becomes unbalanced when a node is inserted into the right subtree of the right subtree. मतलब राइट सबट्री के बाद और एक तो राइट सबट्री क्रिएट करता है, तभी वो अनबैलेंस्ड होता है. Okay, so the tree which is a node which is inserted into the right subtree to the right subtree of the right subtree, we can say it as a unbalanced tree, and we can say the problem, this problem is known as the right problem, because right subtree के बाद right subtree insert होता है, that's why we are saying a right problem. To solve this, what we do, we use the left rotation problem. We are using it once, we are just converting it once, that's why we say it as single left rotation. So now I have a query. Can anyone say me how we are balancing it? See, why I took the 2 here, why I have not took 1 here? The 1 is my root node. Now here in this picture, 1 is my root node. Why I have taken 1 to the left subtree and 2 kept as the root and 3 given to the right subtree? Can anyone say me why I have done this? No one? What have you learned in the binary tree? Binary search tree. Yeah, Himani, say. Why you want to say me? Why?
कि बाइनरी सर्च ट्री में होता है ना कि राइट में मिनिमम आएंगे और सॉरी लेफ्ट में मिनिमम आएंगे और राइट में रूट से मैक्सिमम जो.
Exactly, you are absolutely correct. Thank you, Himani. In the binary search tree, what we do, the value, the root node, this is my root node, is 2 is greater than 3? No. That means in our binary search tree, what we learned, the right subtree's value should be greater than the root node and the left subtree value should be less than the root node. So here, in this single left rotation problem, in this single left rotation, what we did, we divided, we just made the solution. क्या हमने 1 को 1 जो 2 से छोटा है, 1 is lesser than 2, that's why 1 came to the left subtree and 3 came to the right subtree. We balanced it. Now my tree is balanced. See, here my tree is not balanced. 3 is 0, 2 is 0, okay, sorry, 2 is 1, 2 is my 1,
this one
1, and 1 is my how much? Minus 2, right? 1 is my minus 2, because 0, there is no left subtree, that means 0 minus 2, their height is 2, obviously 0 minus 2 is minus 2. So here my tree is not balanced because minus 2 is not a balance factor. We have read before that the balance factors are 3, that is 0, minus 1 and 1, and minus 2 is not a balance factor. But when I done this part, when I rotated it, when I make the rotation of the left rotation, what might become my tree? It is balanced. 1 is my 0, 3 is my 0, and this is my also 0. Left subtree 1, right subtree height is 1. 1 minus 1 is equal to 0. That means now my tree becomes balanced. Clear everyone? Clear in the left rotation? Is there any doubt?
Clear.
Clear. Soumya,
No,
are
Jaya.
you clear? Soumya? Okay, fine, Soumya. Thank you. Priyanka, you clear? Yeah, if Priyanka, I am seeing your messages. Are you clear about this part?
Yeah.
So let's move on to the right rotation. The same happens in the right rotation also. In the right rotation, what we did, in the left rotation, what we did, the tree is our right to right. In the right rotation, the tree is our left to left. See, left to left, our tree. Avail tree may become unbalanced if a node is inserted in the left subtree of the left subtree. See, left to left. We call this as a left-left problem. The tree then needs a right rotation solution. The solution, what we said, the right rotation solution. And what the problem is said, left-left problem. So here my tree is not balanced. See, 0 is 1 is 0, 2 is our 1, and 3 is our 2. Okay, so it is not a balanced vector. It is never a balanced vector. 2 is not our balanced vector. So what we did, we just put the 3 to the right part. We just make a rotation of the right one. Means we did it, the 3 part, the 3 node came to the right side. And 1 is in the left side, 2 becomes our root node. Here the root node is our 3. But we rotated it to make it a balanced subtree, balanced tree. Balanced height balanced tree. So this problem is known as left problem, and the solution is known as right rotation. Clear?
Yeah,
Fine.
clear.
Let's move on. There we are making one rotation. We are just making one rotation. That's why we are saying it. See, we are making only one rotation. Just one node, we bring one node to the right part. We made one rotation. This 3 node came to the right part, and our one rotation is over, and our tree also became balanced. But in the next 2 rotation, that is left-right rotation and right-left rotation, here we have to make 2 rotation. Otherwise, our tree will not become balanced. So in the left-right rotation, it is a double type of rotation. We have to make here 2 rotations to make our tree balanced. In a left-right rotation, it is a combination of left rotation followed by the right rotation. Combination of left rotation followed by the right rotation. That means, see, if 3 is our root node, there is a left subtree of 1, and to the left subtree, there is a right subtree. See, 3 is our root node. There is a left subtree 1, and again to the left subtree, that is 1, there is a right subtree. Okay, so is this tree is our balance? No, it is not balanced. See, here our tree is 0. Here it is become 0 minus 1 minus 1. Okay, and here it becomes 2 minus 0. That is 2. Correct? So it is not a balanced tree. So to make it a balanced tree, what we have to do? We have to just first we have this left-right problem. We have to do it as a left-left problem. We have to convert it as a left-left problem. So that only we can make do another rotation. First, we have to rotate one part. How to rotate one part? We have to take this 2 node. This 2 node we have to take it upward, and one have to come to the right only. Means if this is 3, the 2 part should come to the left of the 3. Left of the 3. The 2 was first in the right subtree of the 1. But now the 2 we have to rotate it. We have to take the 2 to the left subtree of the 3. Then again we have to put the 1 to the left subtree of the 2. Then now it is a left-left problem. That now it becomes our left-left, or it is a right-right problem. It's our left-left problem because our left subtree and left subtree is there. So it is our left-left problem. Now we have to apply our left-right rotation. the normal in the left problem, what we are doing? The right solution we are doing, right rotation solution. So normally we have to do it that previously what we have done. We will take the 2 as our root node. 1 will come to the left subtree and 3 will come to our right subtree. Now our tree is balanced. After doing this part, we have converted to this part. It is also not our balanced tree. To make it balanced, what we are doing? Another rotation we are doing. We are doing this rotation. Again, we are just balancing the tree. That means we are using here 2 rotation. When you are using 2 rotation, so that's why we are calling it as double type of rotation. And this problem is known as the left-right problem, and the solution is known as the left-right solution rotation. Next is our right-left rotation. The second type of double rotation is right-left rotation. It is a combination of right rotation followed by the left rotation. Here, like in the previous part, what you have seen, there is a left subtree, and to the left subtree there is a right subtree. Here, there is a right subtree, and to the right subtree there is a left subtree. So that is what we said as right-left problem. So what we have to do, we have to make one rotation, we have to make it as a right-right problem, then only we can make another rotation to solve, to make it is a balanced tree. So what we did, we just did what? We took the 3 node to the right part. See, we took it here, na, 3, and 2 to the upper part. We made it as a right-right problem. We made one rotation. We made this as a right-right problem. Then after that, again we made a rotation. The 2 became the root here, 1 came to the left subtree and 3 came to the right subtree. Then it is the right-left rotation, and now my tree is balanced. Anyone having doubt in this part, please say me now so that we can move further. Any doubts, please? Those who are unable to talk, can you please text me so that I can know that there is no issue? Then we can move further.
I have a doubt in left-right rotation.
Okay.
Left,
where you
right
have a doubt? Entire left-right. Okay, fine. Okay, Priyanka, thank you. You're clear in this part. See, Shwetalina, in the left-right rotation, this is my node. This is my root node. 3 is my root node. Okay. To the left, there is another node. To the left of the 3, to the left subtree of the 3, there is another node, that is 1. And to the right of that subtree, that means to the right of the 1, there is another node, that is 2. That means which problem it becomes? Left to right. पहले आया 3 से आया 1, वो वाला 1 हो गया लेफ्ट सबट्री, 1 से आया 2, वो हो गया राइट सबट्री. दैट मींस इट इज अ लेफ्ट राइट प्रॉब्लम. मतलब पहले लेफ्ट गया, लेफ्ट से आया राइट, उसी नोड से आया राइट. अगर इस नोड से आया होता राइट तो ये हमारा कुछ इश्यू नहीं होता, लेकिन उसी नोड से हमारा राइट आ रहा है, इसका मतलब हमारा ट्री बैलेंस नहीं. बैलेंस पता करने के लिए हम क्या करते हैं, यहाँ पे सी, यहाँ पे 2 के राइट और लेफ्ट में कोई भी ट्री नहीं है. दैट मींस द बैलेंस फैक्टर इज अवर 0. इस 1 में हमारा यहाँ पे लेफ्ट सब ट्री 0 है, राइट सब ट्री हमारा 1 है. 1 हाइट ऑफ द लेफ्ट सब ट्री 1. दैट मींस लेफ्ट माइनस राइट, हमारा बैलेंस फैक्टर यहाँ पे क्या हो गया, -1. ओके, so what is the balance of factor of the 3? Can you say, Shwetalina, what is the balance factor of the 3?
-2.
-2. It is -2.
-1, sorry.
-1. Get it clear by yourself. Is it -2 or -1 or -2? Obviously, it is 2. Right, Himani? Is it 2?
Yeah.
Yeah. How it is 2? Because here the height of the left subtree is 2, right? The height of the left subtree is 2. 1 and 2. This is 1. This is 2. The height of the left subtree is 2. And there is no right subtree here. Is there any right subtree to the 3? No. That means 2 minus 0, that equal to 2. So 2 is not our balance factor. That means it is not balanced. In the left-right problem, this tree is not my balanced tree. So to convert it into balanced tree, what we have to do? First, we have to make one rotation. To make one rotation, we have to take this 2 value, we have to take it to the upward. That 1 will come to the downward. We will make it the left problem. Without making it to the left problem, we cannot rotate another part. We are making it to the left problem. So 3 is the root node. That's it. 2 became gone to the 1 node and 1 came to the 2 node. Interchanged here. But it becomes left node. Now it is our left problem. Now also our tree is not balanced because it is 0. It is 1 minus 0, that is 1. Now this is our 2, right? Right, Shwetalina? Doubt clear?
Yeah,
Clear in this how it is balanced? Okay, fine. This is now 2. Fine. Now after that we have to make another rotation to make it balanced. 2 is not our balance factor again. So to make it balanced, what we did, we just rotate the 3 to the right side of the 2 and the left is to the left side of the 2. So it is now 0. It is 0 and this is also our 0. 1 minus 1, it is 0. Now it is our balanced tree. Balanced tree. This is our ABL tree. We can say it. It is our ABL. Clear? Clear, Shwetalina?
yeah, I got it.
जयदी 1 मिनट आप लास्ट स्लाइड करोगे?
हाँ बोलिए, ये वाला या पिछला वाला?
इससे पिछले वाली स्लाइड.
ओके फाइन से.
इसमें ये राइट रोटेशन में ना जो
बोलिए.
Okay, got it. Yeah.
Okay, fine. So let's move on to some few MCQs of this AVL tree. A balance factor in AVL tree is used to check what rotation to make, if all child nodes are at same level, when the last rotation occurred, or if the tree is unbalanced. Give me your answers in the chat box, please. A balance factor in AVL tree is used to check what? It's very easy, guys. It will not take so much time. Yeah, Himani, Shwetalina, Swati, okay, Priyanka. Soumya, give me your answer. Soumya, give me your answer. Okay, thank you, Soumya. Fine. So, Shwetalina, just check your answer. When the last rotation is occurred is not the answer. What we do to check the balance factor in AVL? If the tree is unbalanced or not, that's the right answer. If the tree is unbalanced, that means we are checking the balance. We are checking the balance factor to see whether a tree is unbalanced or not. Next is what is an AVL tree? What is an AVL tree? A tree which is balanced and is a height balanced tree. A tree which is unbalanced and is height balanced tree. A tree with 3 children. A tree with at most 3 children. Okay, Priyanka, Himani. Okay. Shwetalina. Soumya, answer. Okay, so fine. So that's not right actually. A tree which is balanced and is a height balanced tree is an AVL tree. If a tree is unbalanced, then how can we say it is a AVL tree? Obviously, we have learned from the beginning. Okay, let me show you. Height balanced tree. Why are you going to the negative part? That is not unbalanced. That is height balanced tree. Clear? Okay, let's see. Which of the following below diagram is following AVL tree property? Take your time. It will take some time, but do it and see. Which of the below diagram is following AVL tree property? No answer till now. Fine. "30 seconds more, guys." Okay, Himani, Setalina. Himani, check your answer. Swati, okay. Both, okay, both. Okay, Soumya, Priyanka, Swati, Svetlana, you're correct. Himani, what happened? Where you got wrong? Answer is B. Himani, where you got wrong? Say me, where is the problem? Where did you got wrong?
सेकेंड वाले में तो ये अनबैलेंस्ड है ना?
कैसे?
13 की बैलेंस फैक्टर कितना होना चाहिए?
कितना होना चाहिए बोलिए? 2 minus 0 is equal to 2.
हाँ.
Okay, fine. Then?
तो ये बैलेंस्ड.
तो ये 2 minus 3 हुआ ना, minus 1 हुआ ना? Is minus 1 is not a balance factor?
-1 तो बैलेंस फैक्टर है, बट 13 तो बैलेंस्ड नहीं है ना?
तो 13 बैलेंस ना हुई तो मैं पूरा ट्री के बारे में पूछ रही हूँ.
अच्छा, ओके.
Yeah, I'm asking about the full AVL tree, right?
ओके, अगर फुल एवियल ट्री हो तो फिर हमने रूट ही चेक करना है मतलब?
जी, didn't get you.
मतलब
आपको वो ऐसे टुकड़ा टुकड़ा करके नहीं पूछेगा, वो आपको पूछेगा अगर फुल बैलेंस ट्री को पूछेगा आपको. या यू हैव टू चेक इट फ्रॉम द बिगनिंग ओनली.
ओके.
Got your answer? Fine. So let's move on. Consider the following AVL tree. This is the AVL tree. Okay. This part is the AVL tree. Say which of the following is updated AVL tree after insertion of 70. 70 insert किया गया है. Okay. So which one is the updated one? Say me in these 4 options, what will be the correct option? पहले ट्री बना के फिर बैलेंस करना पड़ेगा. You have to balance the tree, otherwise it will not called as the AVL tree. Okay, you have to balance it after inserting 70. Okay, Priyanka, give me the answer. Okay, fine. Svetlana, okay. Himani, fine. Soumya and Swati, are you trying now? Shall I give you more 30 seconds? Or I will reveal the answer? Okay, Swati got your answer. Soumya, what's your answer? Are you trying? Okay, fine. The answer is actually C. So Priyanka, where did you got stuck? Why your came answer as E? Priyanka, can you explain why? Okay, don't do like that. You have to just check also it is if it is in a binary search tree or not. Then only you have to see it. Otherwise, it will not come in a balance vector or also not support the AVL tree supports the binary search tree also. Remember it. AVL tree we are saying it as a height balance binary tree also. So remember Priyanka, you have to check that one also. Okay, fine. You did it normally. You have got the answer. That's fine. Yes, it's awesome. Let's see. We have come to our B tree now. Completed our AVL tree. Everyone is clear in that part. We have done the MCQs. I hope everyone is clear in that part. So next we will see B tree. What is a B tree? A B tree is a specialized M-way tree that can be widely used for disk access. Remember, it is used for disk access. Just a minute, guys. A B tree of order M can have at most m-1 keys and m children. So the m order should be, if order is our m in a B tree, that means the keys should be, at most keys should be m-1. So let me ask someone. Svetlana, say me, if my order is 7, what will be my key? Svetlana, can you say me? Okay, fine. See, who said me the
Jaya
answer?
Didi.
Himani. Okay, yeah, Svetlana.
Jaya Didi, actually, I have a doubt on ABL tree. How we create the ABL tree? If matlab,
Okay, Svetlana, let me ask you, were you from the beginning of the session or not?
No, actually, I'm joined
So
later.
that's the reason you didn't get it. Please go through the session, go to the video, then only you can learn it how I had said it in the first part. Okay, first go to the from the beginning, you go from the video, you can know how I have done it. Okay, so
Okay.
let's see what is B tree. B tree, you have said it. You said the if as 7, the order is 7, then we have seen it is 6. Fine, the key is 6. Okay, let me ask Soumya. Soumya, can you say me if my order is 9, what will be the children? How many children we have then? Soumya, I want an answer from you. Can you say me if my order is 9, how many children I have in that tree? Yeah, I hope Soumya is not there now. Maybe some network issue. Okay, Himani, can you say me how many children? Okay, Himani is also not there. Okay, Swati, can you say me how many children?
Yeah, it would be 9 children.
Yeah, correct. Absolutely right. That means if my the order is same as my children, and the keys is -1. 9 minus 1, that is 8.
Eight keys.
Yeah, correct. So one of the main reasons of using B tree is its capability to store large number of keys in a single node and large key values by keeping the height of the tree relatively small. Lots of keys can be kept here. That's why we are using this B tree. B tree is a self-balancing search tree. Okay, self-balancing search tree. It can do it by itself only. When the number of keys is high, the data is read from disk in the form of blocks. In addition, it contains the following properties. Let's see about the properties. This is very important. Please, guys, if you can just note down these properties. That will help you in the further MCQs. Please note down these properties. Every node in a B tree contains at most m children. At most, it will contain m children. Okay. Every node in B tree except the root node and the leaf node contain at least m by 2 children. A B tree with order P has maximum m minus 1 and minimum m by 2 minus 1 keys. Ceiling of m by 2. Okay, means m by 2. It's 2. Sorry, guys, it's 2. M by 2 minus 1. It's the ceiling. Ceiling. I can't find that symbol actually. That's why I written here ceiling. Ceiling means this one. Means if my m is 6. See, if my m is 6 by 2, that is 3. 3 minus 1, that is 2. That means my m by 2, that is 2. We have the minimum or keys as 2. And maximum should be m minus 1. All leaf nodes must be at the same level. The leaf node must be at the same level. Not if this will not happen like this. See, this one, if my tree is this one, here I made a leaf. These two are leaf node. Here is also my leaf node. So this is not in the same level, right? This is in the 1 level. This is in my 2 level. This node is my 1 level, and these 2 nodes are in my 2 level. So it will not happen like this. All the leaf nodes should be in my same level. Clear about this part? Everyone retain this, remember these properties? Shall I move on?
Please wait.
Okay, fine. You are writing? Okay.
Yeah.
Over. Shall I move on?
Yeah.
Okay, fine. See, I have done an example here. Construct a B tree of order 3 by inserting number from 1 to 10. We will make a tree from of order 3 and we will insert number from 1 to 10. My order is 3. That means my key will be 3 minus 1. That is 2. That will be 2. Okay, fine. So let's see. First we'll insert what we'll insert. 1. I have inserted 1. Do it in your copy by my I am doing simultaneously. Do it me. There is 1. We have inserted 1. Second, we will insert 2. I have inserted 2. Because my key there will be 2. I can keep 2 keys. So I have kept here 2 keys. This is my 1 node. This is my 2. 2 keys I have kept here. Second, when 3 will come, it will not take 3, right? Because if you will take 3, already I have said my key is 2. I have to take here 2 keys. I can't make a diagram and do a 3 here. I can't do it. It will not accept that. So why 3 will wait there? We'll make a rotation here. We will make a rotation and we will divide the tree. See, my 2 go on to the root node, 1 came to the left subtree and 3 gone to the right subtree. That's it. Now we will insert 4. Where we will insert 4? Can anyone say me where will we insert 4? Either we will insert here or here. Where
The
we will
right
insert?
side.
Right side, correct.
3.
Priyanka, what you said? It is cell left or right?
I said net 3.
Left side. Why it will be in the left side, Priyanka? Because of, see, it is a binary search tree. 4 is greater than 2. Obviously, it will be in the right side. It cannot be in the left side. Because 4 is greater than 2. It is a binary, so we are using binary search tree here, right? So 4 is greater than 2. That's why we will insert in the right side. Then our came 5. 5 cannot be inserted here because it is a key. We have a key of 2. We cannot insert it here. So 5 will be inserted. The 4 will goes up here. 4 will goes up here. And 5 will come to the right side. 3 will make another node and 1 will make another. Got it? Then
Yeah.
next is our 6. 6 can be inserted in the right side. Yeah, it's no issue to insert a 6 because we have 2 keys now. We can insert 6. Then when it will come to 7, our order is 3. Then it come to 7. Our key is 2. If the 6 will goes up here, if the 6 will goes up here, because we'll take the largest value, not the. If 6 will goes up here, what will happen? It cannot insert here because we have the key of 2. We cannot insert it here. So again it will divide. Again the 6 goes up here now, but it cannot insert it here. Why it will insert? Because it a key of 2. Now we cannot insert 3. So again it will divide. It will divide it into this part. 4 will goes up, 2 will come to the left one, 6 the largest one will go to the right side, and it will make this tree. See, it's so easy. Then again came our 8. 8 can be inserted here easily. 8 can be inserted here. See, 8 is inserted. Then when 9 come, 9 cannot be inserted here. Then 8 will go to the up part. 8 will be inserted here. And 7 will form 1 and 9 will form 1. See, done in this part. 7 will go 1 and 9 will go to the 1. Then came our 10. What will 10? 10 will be inserted easily because there is no 2 keys. No, there is only 1 key. 10 will be inserted easily. It's as simple as that. Clear? Anyone having doubt? Ask me. It's very easy. Very easy. When you will try it by yourself, it will be very easy for you. Okay, fine. Everyone is clear in this part. Let's move on. MCQs. As usual, after some part, I give some MCQs. Give me the answers. A B tree of order 4 and height 3 will have a maximum of dash keys. Order is 4. Height is 3. See me. What will be the answer? Try. Take some time and try. I'm giving you a formula also. Just try it. The formula is m to the power. Okay, Priyanka, got your answer. M to the power h plus 1. Yeah, Priyanka, got your answer and you are absolutely right. Okay, guys, I hope you are getting some confusions in this question. So, okay, Let's see the answer. What it is? It is 255. See the formula. Okay, Himani, got your answer? Wow, everyone got the answer. Okay, fine. It is m to the power h plus 1 minus 1. Okay, so I forgot to return here minus 1. Sorry, guys. I forgot to return here minus 1. So a B tree of m height, a B tree of order m. Here our order is 4. That means order is our m. And height is 3h. Take the height 3h. We'll have maximum number of keys when all nodes are completely filled. So the B tree will have n equal to nodes. That means keys. N is equal to our keys. That means how many keys we have? M to the power h plus 1 minus 1. So m is our 4 to the power 3 plus 1 minus 1. Okay, 4 to the power 4, that is 256, minus 1, that is 255. Everyone is correct. Thank you so much, guys, for listening so carefully and doing by yourself. Thank you so much. Everyone is correct with your answer. Somya, did you got how it happened? You didn't give your answer. That's why I'm asking you. Did you got it? Okay, fine. Next query is 5 node splitting operations occurred when an entry is inserted into a B tree. Then how many nodes are written? Means it's saying that if 5 splitting is there, then how many nodes are there in the tree? 5 splitting, 5 rotations, 5 splitting you can say. Split. We are splitting the value, na? So when we are splitting it 5 times, how many nodes will be there in the tree? Getting, guys? Getting the answer, or shall I reveal it? No one is getting answer. Okay, Himani. Okay, Himani. Got your answer. Himani, can you explain me what you have done? Okay, Priyanka also got me. Now, after giving the answers, Himani, please can you explain me how did you did it? Swati, are you getting it? Or shall I reveal the answer now? Swati, Svetalina, Soumya.
Yeah, Jay, you can reveal this answer. I'm not getting this.
Okay, fine. So, see. Answer is C. Absolutely right, Himani and Priyanka, who gave me the right answer. Thank you so much. Himani, can you explain how you get the answer? How did you do it?
उसको 2 के साथ मल्टीप्लाई करेंगे +1.
Oh wow, correct. That's absolutely right. The splits occur. तो splits जब B tree में occur होता है तो उसका ये formula है 2s plus 1. S is our split. Here our split is 5. So 2 into 5, that is 10 plus 1. 10 plus 1 is our 11. This is the actually formula. We can do it by this only. That's the formula actually. That's easy to do it. So let's see next query. Figure shown below is B tree of order 5. What is the result of deleting 130 from the tree? This is the figure actually. This is the question figure and these are the options figure. So see, in this question, it is saying that the B tree is the order of 5 and what if we will delete this 130? I will delete this 130. Then what will be my actual tree? See guys, this is my 110 actually. It's wrongly written. Don't get confused. It is 110. So take your time. I'm giving you a 2-minute time only. Give me the answer in this, in between this one. This is quite easy. This is quite easy. Okay, Shomya, give me the answer. Fine. Shomya, just check your answer. You gave me the answer. Yeah, you have tried it. I got, but just check it. Guys, more 30 seconds. No one getting the answer? Fine, let me reveal it.
B or Neha?
B. Okay, B. Svetalina also said me B. Priyanka said me B. Himani also said me B. And Swati, what's your answer? Okay, C. Swati's answer is C. So, Swati and Soumya. Okay. And Himani, you are guessing it is B. Okay, you all listen the answer. It is actually B. Thank you, Priyanka and Svetalina. So, here we can't take C or D because we have the order of 5. So if we have the order of 5, I have said one of the properties you can see there. We can have minimum of m minus 1. So here 110 is there. M minus minimum value should be at least 2 keys should be there in one node. At least 2. The order of 5 must contain at least 2 keys. Obviously it will contain. It cannot contain 1 key. Here it is 1 key. 1 key. It cannot contain. That means C and D is already omitted. Okay. So here when the key is 130 is deleted. 130 is where is 130? It is deleted. When we delete it, it becomes 1 key. So 1 key cannot be happen. So this 2 is deleted. These 2 options is deleted. After that, what we will do? We will combine the key with this part 140, 144, 156. We will combine with this part. Okay. When we'll combine it, then it will come to the means 110 will go to the 144 and 156. It will combine with 144, 140 came down here. And this combination becomes a separated key from the parent key, that is key 140, leaving the root with 2 keys 110 and 160. It left to it's left the parent key and came here. 140 came here. It becomes a separator. That's it, nothing else. These two cannot happen because of it is a underflow condition. It cannot be 1 key. At least 2 keys should be there. It cannot be 1 key. So this is the thing. So answer is B. So let's move on. In a B tree of order 5, the following keys are inserted. 7, 8, 1, 4, 13, 2, 20, 2, 6 and 5. How many elements are present in the root of the tree? How many elements are present? It's very easy. It's very easy. How many elements are present in the root of the tree? Okay, Shwetalina, give me the answer. Priyanka, give me the answer. Okay. Mani, what's your answer? Swati, answer. Swati got me the answer. Okay, Swati. Okay, Swati, you have given me the answer as D. Conflict answers are coming. Okay, fine. Let's see what will be the correct answer. Imani gave me the answer as D also. Soumya, what's your answer? Okay, D. Yeah, guys, it's only D. Cannot be 3. How you get the answer as 3? It cannot be. Okay, Priyanka. Okay. Priyanka changed your answer. Okay. It is D only. You do it by yourself. Again, try it, Shwetalina, by yourself. You will get to know the answer will be only 2. There will be 2 nodes in the root hole. So next, the number of disk access performed by insertion operation B tree of height h is what is the time complexity by inserting it? I have not taught the insertion part or the time complexity. It will take big O of h. It will take the height only. It will take the height. It will go by height now. It will see first height, then second height. It will go by height only. The answer will be C. Order of h means order of height. Okay, clear? So let's move to the B plus tree. What is B plus tree? Let's learn. This is our last part only. Just have some patience. B plus tree is an extension of B tree which allows efficient insertion, deletion, and search operations. In B tree, keys and records both can be stored in the internal as well as leaf nodes. Whereas in B plus tree, records can only be stored in the leaf nodes while internal nodes can only store the key values. So in the B plus tree, what you will get? A sorted array. You will get in the B plus tree a sorted array. In the leaf nodes only, you can get the records and data. Sorry guys. In the leaf node, you can get the records also. The records which are present in the internal nodes, you can also get it in the leaf nodes. The leaf nodes of a B plus tree are linked together in form of a singly linked list to make the search queries more efficient. What you do in the single linked list? This is our single linked list. What do we do? The second part is storing the address of the first part. Yeah, the data is stored here, the data is here, the data is here. It forms like this is the means what? Here it is null. Okay, Here it is storing the value of the address of the first node. So in the singly linked list, what you do? The second node is storing the address of the first node. In this B plus tree, it happens also like that. It is linked in such a way like it is linked in a singly linked list to make the search operations more efficient. When you want to search one node, if you want to search this node, it is very easy that it is connected with this. The address is stored here only in the first node. That means it's easy. That means this node is available in the second part. We can search it here. It's quite easy. That's why the B plus tree is used. It is an extension of B tree because it's very efficient in insertion, deletion, and searching operations also. So what are the properties? B plus tree is also a height balanced tree. Key value is in a sorted order. If you get all the data in the leaf node, that means all the key values are in the sorted order. You can find it there only. You have no need to go to find all the heights, go one by one, traverse one by one, see where it is or not. Just go to the leaf node and find all the nodes there. That's the B plus tree. Leaf node has pointer to next leaf node. First leaf node, like in the singly linked list, what we do? First node is being pointing to the second leaf node, like second node. In the B plus tree also happens like that. The first node is pointing to the second node. That will be easy for you to understand. To search any kind of node. Non-leaf node has pointer to a node, leaf or non-leaf, and not pointer to data record. The node which is a non-leaf node, that will only point to the node. Means if this is my tree, okay, this is my B plus tree, then the non-leaf node, this is my leaf node, these are my leaf nodes. The last part is our leaf node. Those leaf node, which are we saying the leaf node? Those don't have the children node. So these are my leaf nodes. These are pointing to each other. Okay, these nodes are pointing to each other. But the non-leaf nodes, means these nodes, this is my non-leaf nodes. They do not point to the data record. They don't point. We can't point it here like this. We can't do like this. Only the leaf node can point themselves, but not the non-leaf node. They only point to their own children. They only point to their own children. They can't point themselves. That's it. That is the main property of the B plus tree. Nothing else is there. In the B tree, what you are doing, the same is also doing in the B plus tree, but in the B plus tree, what you are doing, in the non-leaf nodes are connected to each other. That is the reason we can search it easily. Clear? Any doubt? We will see one example, then you will clear in all these doubts. Till now, are you clear with these properties? Okay, let's see the example. Construct a B plus tree of order 3, inserting number from 1 to 10. B plus tree, order is 3. Then what will be my key here? My key here is, what is my key here? Yeah, Himani, what's the key here?
2.
2, correct. Your key here is my 2. So I have inserted 1 first. Yeah, Swetanina, 2. I have inserted 1. Then I have gone to the 2. I will insert 2. I inserted 2. It's easy because my key is 2. I can keep 2 values. Easily kept 2 values. Then I will insert 3. But 3 cannot be inserted because it will become key 3. But key 3 cannot be inserted. So what will do? 2 will go upside. It will point to 1. And 2, 3 both will be written here. 2 will be also written here, so that we can point up. All the values will be written in the leaf nodes. All the values which will go to the root also, which will be in the non-leaf node also, all will be written in your leaf nodes. So 2 is gone up to the root node, 1 to the left node, and 3 came to the right node. And 1 is pointing to 2, because here also 1 was pointing to 2. So 1 is pointing to the second node. Then came my 4. 4 cannot be inserted here. So 3 gone to the upside. 1 came down. 1 pointed to 2. Then 2 pointed to 3. And 4 is inserted here. Okay. Again came 5. 5 cannot be inserted. because 2 notes can be only inserted now. So what we'll do? 5 is again 5 will go to up, but cannot be inserted. 5 will be here only, right? 4 in 5 here. 3 goes to up, 2, 4, 1, 2, 3, 4, 5. These are the leaf nodes who are pointing to each other. See, Himani, have you any doubt?
No doubt.
Okay, fine. So next came 7. Again 7 will be inserted here. 5 will go to up because 5 cannot be inserted here. So 5 gone to up. See, same is the process. 3, 4 came here. 2, 4, 6. Again, all the nodes you are finding in bottom only. See, all the nodes are in the bottom only. Here came 3, 5, 2, 4, 6, 7. 1, all the bottoms are here. Again 9 came. When will be 9 inserted? 9 will be inserted here. 7 will go to the up. Again 7 cannot be inserted here. So it will again divide. 5 will divide to 3 and 7. 3 will divide to 2 and 4. 7 will divide to 6 and 8. And as usual, all the nodes are in the down. Same wise in the 10 also. 10 also. 10 if inserted here. Finally, I got the tree like this. 5, 3, 7. 3 to the 3 there is 2 and 1. And to the right it is 4. And to the 7 it is 6. And 5 to the right is 8, 9, 9 and 10. That's it. Just all the nodes are connecting to each other. Nothing else is done. The B tree, what you have done in the B plus tree, that is done in the B plus tree. Just all the nodes are connected to each other. See, all are pointing. The first one is pointing to second, second is pointing to third, third is pointing to fourth, and so on. That's it. Nothing is there in the B plus tree. So next, move to our MCQ. So B plus tree are preferred to binary tree in database because disks are more reliable than memory. Disk access is much slower than memory access. Disk data transfer rates are much less than memory data transfer rate. Disk capacities are greater than memory capacity. Which will be the correct answer? Which will be the correct answer, guys? Okay, Swati, got your answer? No more answers? It's easy, right? What I've learned from the beginning. Okay, not getting the answer. Okay, B. Himani. Okay, fine. Yeah, everyone is correct. That's fine. Disk access is much slower than memory access. That's correct. If you will store one by one, then obviously the disk access will be slower. Fine. Everyone got the answer then, right? Next is, what is maximum number of keys that a B plus tree of order 3 and height 3 have? Yeah, Priyanka, got to know. Fine, it's fine. But you are giving the answer. That's correct. What is the maximum number of keys that a B plus tree of order 3 and height 3 have? What will be the answer? It's easy. Okay, Himani, what your answer? Fine, no more answers. Okay. Answer is D actually, Himani. Swati, okay, fine. Giving the answer. Answer is D. See, a B plus the tree of order n and height h. See, the utmost keys should be n to the power h minus 1. This is the actual formula. So our n is here 3, height is 3. Okay. So our answer is here 26. Fine. A B plus tree of order 3 is generated by inserting 89, 9 and 8. The generated B plus tree is what? Order is 3. Inserted 89, 9 and 8. What will be the B plus tree? It's easy. Very small numbers are there. What will be the answer, guys? It will not take so much time. It's very easy. Am I not audible to everyone? Okay, fine. Got the answer. Okay. Shweta, Dipu, fine. Priyanka, okay. Wait, Swati and Himani, what's your answer? Okay, Himani, what your answer? Swati, what's your answer? Okay, fine. Yeah, you are absolutely right. It's B only. These two will not happen because they are a no pointer mark. Cannot be happen. And this cannot happen because it's not pointing to 9. Your 9 is not written. So B is the correct answer. Right. Last one. A B plus tree can contain a maximum of 7 pointers in a node. What is the minimum number of keys in leaves? 7 pointers are there in a node. That means how many keys are there? It's quite easy. It's very easy. 7 pointer. That means how many nodes? How many keys should be there in the leaves? Okay, Himani, what your answer? Okay. Minimum number of keys, Himani. Okay. Okay, Shwetalina, Priyanka. Fine. Swati, okay. Soumya, what's your answer? Okay, fine. So let's see what's the answer. The answer is actually B and everyone is correct. I have said you at least there will be n minus 1 by 2 keys. The ceiling of the n minus 1 by 2 keys. Yeah. Everyone is listening so carefully to the class and thank you so much for listening so carefully and giving the answers correct. Thank you so much, guys. And having any doubt?
No doubt.
Okay. Thank you so much. Thank you for listening so carefully to the classes. Thank you so much.
Thank you.
Thank you.